All right, so this is actually going to be the last recording of the entire semester. Of the semester, yeah, or year, I guess, if you will. So we are going to talk about similar stuff to what we did yesterday. So if you were not here, you definitely want to pay attention because what we did yesterday, it follows similarly to today. The idea being, yesterday we focused on using which form? Which form do we use? Well, it's a quadratic function, but what form of that function? Not standard form yesterday. Not standard form. Vertex form. So vertex form was yesterday, and we learned how to find all these different things. All right, do you guys remember the things that we found? Up and down. Awesome. We're going to find those same four things today, but as you read, we're not going to use the vertex form. We're going to use the standard form. All right. Now, it's okay. You shouldn't hopefully be grimacing too much because you actually have seen this form before. We saw this before Thanksgiving. Just think back to when we solved quadratics. I'll just say, for example, do you remember the quadratic function? I don't know why I said function. Formula. Remember the song that we sang? Yeah? X equal to blah, 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 right? If we're going to use that formula, the quadratic must be in this form. Okay? So you've seen this already. All right? So that's no different. What is different, though, is how we're going to use this form to find all of those pieces of information. So the next slide is blank. On purpose. Because I want you to write everything that we need to find these four things. So we wrote this down yesterday, but which form did you write down yesterday? Vertex form. Today you're going to write down standard form. All right, so you should fit this into that box. Yes? So Vincent had a really good question that I think everybody might want to listen to. I think your question was, am I going to make you go from vertex to standard? The answer is no. That is a skill that you're going to end up doing in pre-calculus. Okay, so I'm not going to test you on that in this class. However, though, Vincent, you are responsible. If I give you a quadratic in either form, you need to be able to use this to find all of the stuff. All right, that is definitely going to be on the midterm. And it's going to be on our quiz next week. I do have the slides from yesterday. Absolutely, you got it. I'm not going to do it right now because it's not important. Is that we can wait till later? Great. Now, I hope that you should see that to find whether it opens up or down, it's no different. We're going to look at whatever is at the very beginning of the quadratic. So if there's nothing there, then it's going to open up. If there's a negative, it's going to open down. That'll be a reflection opening down. The axis of symmetry and the vertex are going to be a little different. We haven't used that formula before. But again, I'm not asking you to memorize it. I'm going to give you all of this on the midterm and on the quiz. The reason I'm having you write it down, though, is I think it is important that you write down how to find these things. All right? Now, just like yesterday, all of you with enough practice will be able to find all of these things. I'm very confident in that. The thing that students struggle with is then how to transfer all of this to the graph. Right? Because the whole goal of today is to graph these parabolas. All right? If you can't do that and you can only do this part, I mean, that's nice, but that's not the whole goal of today, is you have to be able to graph. So that's what we're going to be looking for today. Okay, I'm going to go ahead and get started. I can put this back up later. That way you can finish writing it down. Again, you're going to receive it. And actually, all of this is on the midterm review that you received yesterday. Obviously, if you weren't here, Marcelo, yes, that's something I will give you later today. Here we go. Let's try this one. We have the function in standard form. In this one, I first want to write down what a is equal to. What'd you do, Marcelo? A is equal to 1. B is equal to -4. And C is 6. All right? You always want to write those down first, just like we did when we did the quadratic formula before Thanksgiving. All right? Always write those down first. I'm going to be looking for that today. Do you write down A, B, and C? All right. Does it open up or down? If you look at the very beginning, what is there? Isn't an up, isn't there? There's nothing there. So it is a positive. I notice it is a 1, but positive is the thing I care about. So it is up. All right, so this is going to open up. So it'll be a happy parabola. Okay? Now, the axis of symmetry. This is where you're going to use the formula x equals the opposite of b over 2a. All right? And if you're wondering, where did that come from? They actually use the quadratic formula to find all this stuff. All right? So if you notice, if you start singing the song, a lot of this stuff is going to look familiar. Okay? All right, so I'm just going to plug in. Wherever it says b, I'm going to write what? -4. Wherever it says a, I'm going to write 1. So if you do the math, what do you get? You get 2. Now, I have a couple of ways to go about doing this, and it just depends on the way that your brain works. Some students will do -4 divided by 2. What's -4 divided by 2? And the opposite of -2 is 2. Some students will say, what's the opposite of -4? +4 divided by 2 is 2. Some students, and this was me, I count the number of negative signs. There's 2 of them. That's an even number. It will be positive. If you count and there's an odd number, it will be negative. All right? Yeah. Odd number? Negative. Okay. The vertex. Now, if you think back to yesterday, whatever we found here had to be where? The x in our vertex. Okay? So that still is the same from yesterday. Whatever you get for the axis of symmetry is already a part of your vertex. All right? Because remember, the axis of symmetry goes through the vertex. Okay? Now, if you look at your notes that you wrote down, it says, how do we find this other piece? It's not f times, right? F parentheses a number does not mean f times. Well, what does that mean when you have f parentheses of 2? You plug it in. So we're going to write f of 2. So I have 2 squared minus 4 times 2 plus 6. Again, big thing here, because you guys are going to mess this up today. Not all of you, but some of you will mess it up on an example later. Always use parentheses when you plug in this number. Always use parentheses. Yeah. Yeah, so whatever you get here for the axis of symmetry is the x value for your vertex. And then if you want to find the y, you plug in the x into that function, that 2 into the function, and whatever this is your y. Did that help? That didn't help.
Where'd you get that 2?
This 2.
No, that one?
This 2.
Yes.
This 2 is from that number, which is from that number. So really I got it from there.
And that one is 2?
All of the 2's are from this 2 for now. So like if I would have had this is equal to 4, then I would have been plugging in 4.
So it would be f parentheses 4.
Exactly. Yep, before. All right, so did we get what that answer is? It's another 2. Now, I want to be very clear. That 2 is a coincidence. It's not always going to be the same. All right, it's okay if it is, but that 2 was just a coincidence. This 2 here, the x of the vertex, and that 2 over there in the axis of symmetry have to be the same. All right? Any questions? All right, the y-intercept, the last thing. That's always 0c. 0c. So 0, 6. If you forget and you're like, I don't know why it's 0c, What did we do yesterday to find the y-intercept? We plugged in 0. So I can do the same process, but plug in 0. 0 squared minus 4 times 0 plus 6. What's 0 squared? 0. What's 4 times 0? 0 minus 0 is 0. So nothing plus 6 is 6. So that's why it's 6. All right, so it's always 0, C. Now would be the time to ask questions about how I found any of this stuff, because you'll be asked to do this shortly. No questions? Yes, David. Which 2? There's a lot of 2's. This 2? This 2 is, I just did the algebra here. So this is 4 minus 8 plus 6 if you go left to right. 4 minus 8 is negative 4 plus 6 is 2. Now that's a coincidence that that one's also 2. So that these may not be the same. What has to be the same is that 2 and that 2 has to be the same, always. Okay? All right, now, this is nice, but it means nothing if we can't graph it. We want to graph it. All right, so go to the next slide. Now you have a blank coordinate grid, and let's graph it. What did I graph first yesterday? The vertex, very good. And the vertex for this problem is 2, 2. What comes after the vertex? What is that called? The axis of symmetry, very good. Now, if you weren't here yesterday, the axis of symmetry always runs right through the middle of the parabola. But it's not a part of the parabola because the parabola is a curve, and this is a line. So how do we show that it's not a part of the parabola? We make the line dotted. So please make your axis of symmetry dotted. Now, you can always make that dotted line through the vertex. If that dotted line doesn't go through the vertex, something is wrong. All right, what did we graph after that?
0, 6,
the y-intercept, 0, 6. All right, and that's all we have besides the fact that we know that it's going to open up. But before I can draw this parabola opening up, I need what?
More points.
Need more points, because there's more points on here that it can go through that's on this grid. And we should have a free point. All right, I see 0, 6, which is how far away from the axis of symmetry. It's 2 units away. So on the other side, we get a free point at 4, 6. There's a free point at 4, 6. Again, you could make your curve now, but you may not go through all the correct points because we have gaps. If you look at the x-axis, we have 0 has a point, 2 has a point, and 4 has a point. So we're skipping numbers there. Which numbers did we skip? 1 and 3. Now both of those are 1 unit from the axis of symmetry. So it doesn't matter which one you pick. They will give you the same y value. Which one would you like to plug in?
1.
All right. So we're going to plug in 1. So it'll be 1 squared minus 4 times 1 plus 6. I'm hearing people say 3. So what ordered pair am I going to plot? 1, 3. I plugged in 1, and I got 3. So 1, 3. All right. So I'm going to plot 1, 3 on this graph. 1, 3. Now, I told you right before we did that, we could have also plugged in 3. And it doesn't matter. You also get 3 for the y value. So we get a 3.33. Now can I make it?
Yes.
You could, but do you know if there's another point on there that it can go through?
Yes, there has to be another one.
I don't know ones that have to, right?
Could be
There
another
could be another one. So now we have 0, 1, 2, 3, 4 is all good. What's after 4? 5. What's to the left of 0?
1.
So it doesn't matter. You plug in -1, you plug in 5, you'll get the same y value. Which one would you like to plug in? So Jacob, you plug in -1. I picked 5. If you pick -1 and do the correct math, we should get the same thing. We get 11. Is 11 available to plot on our y-axis? It's not. So are you expected to like draw an extra one and plot it? You're not. If it's not on the grid I give you on the quiz or the midterm, then you're not expected to graph it. Okay? But did you know that until we checked?
No.
No. So you can't just be like, oh yeah, I think I'm good. Right? You got to check. You have to check. Okay? So we actually are okay to graph right now.